When you collect data, you need to, at some point, communicate that data to someone else, and it's helpful to first summarize the data. So we're going to look at categorical first, also called qualitative, but we in this class call it categorical data, and see good ways to summarize the data. So to summarize categorical data on a categorical variable, we're going to use percentages as numerical summaries. So in other words, we'd calculate the percent of whatever we did, and we'll see an example down below. And we're going to use bar charts as graphical. Now, a picture is worth 1,000 words. And so as we go through the example, hopefully you'll see that yes, it's good to have the numerical summary, but you're also, if you can, have a graphical, in other words, a picture summary. Once again, a picture is worth 1,000 words. It's much easier to communicate ideas sometimes using pictures, actually most of the time. Now, if you've taken statistics before, you may say, well, what about pie charts? We did pie charts, you see a lot of pie charts. So a pie chart could be something like this, and maybe what you're interested in is this part, and that's very clear. So let's say this is, oh, I don't know, 74%, and the rest of this is 25%. And that's great. That's easy, very easy to see visually. But what happens frequently with pie charts is you'll end up with a couple little bitty slices and then maybe slices that it's really, oh, and that is not in the center. Apologies. So you got a couple little slices there, but it's really hard to tell, do any of them dominate? What's going on in here? They're hard to do well. So we're going to focus on bar charts. So let's do that using an example, nutritional information. So this comes from a Gallup report back in 2018. And the question was, how much attention do you pay to the nutritional information that's printed out on all food packages? And the options were that people were given, whoever was asked, you could either say a great deal, fair amount, not much, or none at all. And here are, I should say, the percentages of the people who responded. That 32% responded a great deal. And you're like, well, how would I know that's percent? Well, as you can see here, first of all, we usually use percent as numerical summaries. And we're asking, let's say, 50 people. Of those 50 people, 32% felt this way. You'll notice that if you add these up across, we want to make sure we account for everyone. So if we account for our full sample, what would the percentages have to total? And without a calculator, hopefully you can say, well, they would have to total 100%. Now, some students will say, well, what if instead of, you know how sometimes you'll get a survey and it'll rank it like 4, 3, 2, 1, 0. And instead of giving it a very obvious category like great deal, fair amount, not much, none at all, or no opinion, what if we gave it numbers? Does this make it quantitative? No. It's tempting to say, well, it's quantitative because I could add these numbers up, and then based on do a weighted average and then see where it is. It is still categories that we're looking at. So that's one thing that actually people do commonly, even people who are well versed in statistics. Well, not those who are well versed in statistics, but you'll see a lot that you'll get an average, a weighted average of these numbers. But in reality, it is still categorical. And we'll talk more about that as we go along in the course. So then we're given some information about how these telephone interviews were conducted. It tells us the sample size and who was sampled, where they lived. And down the road, it says for results based on the sample of national adults, the margin of sampling error is plus or minus 4 percentage points at the 95% confidence level. You'd be like, whoa, 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 whoa. We haven't done anything with that yet. Right. That's way later on in the course. I'm just giving you, this is some good information about how the survey was conducted. And we'll be using this later on. So identify the following. I'd like you to pause the video, take a moment, and write down based on what you've seen here, based on all this information that's given to us, the observational unit, the variable, population, and the sample. Also indicate whether the variable is categorical or quantitative, and whether, if it is categorical, whether it is binary or non-binary, and then come back and check your answer. So the observational unit is each US adult. Could you give more information? Yes, each US adult would be adequate in this case, but obviously if this was like a multiple choice, if you had each adult, that wouldn't be sufficient. If you had each US adult, that would be the better answer. But once again, in multiple choice, choose the best option that is listed. The variable being how much attention a person pays to nutritional information, it is categorical, and hopefully you automatically see, well, oh, wait a minute, there are one, two, three, four, five possibilities. So it cannot be binary. Binary, there'd only be two. The population we're interested in is all US adults. Well, can we ask every US adult how they feel? No. So that's why we're going to take a sample, and we chose a sample of 1,033 US adults. Remember, if I'd said what is the sample size, all you'd have to do is say the 1,033. Just as a recap or a review, you notice I say each US adult for the observational unit. I use the word each. It's important in that we look at each one of the people that we sample, or each one of the things that we sample, to record the information that we get from what's varying from person to person. Then sketch a well-labeled bar chart. Now, these, we want to be careful in that, trying to draw as straight as possible. So I was quiet there for a moment. We always want to label our axes, and hopefully you remember this from math. You always have to label your axes. So my y-axis, let's see, well, what am I going to put? Well, what I want to do is display this information here, down here. All right, so hopefully you have your paper in front of you and you can take a look at those numbers. So I'm going to label the axes as, well, what am I recording down below? Well, I'm recording how much attention, and I'm going to do a little bit of abbreviation here, US adults pay to nutritional information. We're going to want to do buckets in this case, and we're going to have them separated a little bit because remember, these are categories, all right? So what would be more natural to you? To go from high to low or low to high? Well, my background's in math, and so I usually think about going from low to high. You can go high to low, but just be careful. You need to be consistent as you go across and make sure you label things adequately. So what do I mean by that? I'm going to go low to high. So in terms of no opinion would be the quote unquote lowest in this case. And we had actually, excuse me, none of them. And then none at all. So they don't pay any attention. Not much. A fair amount. And a great deal. So now we have each of the 5 buckets that we had, and we know it's recorded in percent. Are these going to be perfect and exact? No, we're doing this manually. Can you do this using a computer program such as Excel or a statistical program? Definitely. But I want you to understand how these are generally generated. So none at all we see is 9%. So I would do that and say, I'm going to put the 9 in here. Is it absolutely required? No, but it does help to clarify. You will see that as an option if you use Excel, for instance, or the Google Forms to create that. Not much was 21%. So I'm going to make that roughly twice as high as the 9%. A fair amount is 38%. So that would hopefully, you want to make sure that's is the tallest one. And then we have 32% for a great deal. Could I have done this with a pie chart? Yes, but honestly, in the pie chart, the 38, 32, and the 21 are going to look very similar. This, I think, is a better way to display the data. So we will not be using pie charts here. I will ask you to look at a pie chart and see, maybe what's going on with it or why it wouldn't look, why it's hard to read or why it was done incorrectly I believe in one of the discussions for the class. What should once again these total? We want to make sure that we represent everyone. And if you total up these percents, you'll get to 100. And that takes care of how we're going to look at categorical data in terms of summarizing it.